So before we get to actually looking at how to design a frame like a QAV250, we need to look at why it's such a good frame in the first place, which is because it's a unibody design. Now, why would they go for a unibody design? Well, first we need to examine what happens during a crash, which obviously happens fairly often. What happens during a crash is that when it hits, it distributes the force between the entire object. Now, how do we find out what the force is? Well, we first need to use the equation F net equals mass times acceleration. So if our mass is about 550 grams, we're going to have a 0.550. And just for the simplicity of this video, I'm going to be just using 9.8 meters per second squared, which is the acceleration due to gravity. So this is just, oh, I dropped that out of my window on accident, not, oh, I was racing and I hit the ground. That's going to be a greater force because we have a greater acceleration towards the ground. So if our F net equals m times a, so let's just say that 9.8 times 5.550 is going to give us that number right there, then we can then see what happens during a crash. So if we take a frame like mine, and I'm just going to use the Apex 250 as an example, and we hit the ground kind of hard on one arm, all the force is going to travel through that one arm, and then that arm may possibly break because it's only taking all the force from that significant crash and it's taking it all into that one object. Now, for a unibody frame, we can see that if we hit the ground with one specific point or two specific points, we can see that the entire force is distributed throughout the frame. So then the force is distributed to the main body where then it's able to dissipate and the frame is able to take the hit instead of getting too much force and then breaking the object. So that's why that you see unibody frames such as the Alien 5-inch do it very well and that they don't break. Now, a failure of this would be the QAV-R. We're going to examine what happened to this frame and why there was such a failure. Well, they came out and they fixed it by releasing plates. So we're going to look at why that frame broke when the Alien 5-inch didn't, and it has to do with the same concept. But that's going to be for another video, so let's get to AutoCAD and let's get to designing. All right, so once we've opened up AutoCAD, you'll see that I have a image, and also over here I have a new drawing. This is what we're going to be making today, so this is just going to be our basic drawing, and then on Wednesday we're going to learn how to make this into an actual 3D printable model, and then we're going to do some fancy stuff to make it so that it distributes the force even better. So over here we have our dimension sheet. Now this is what you would draw yourself, either on a piece of paper or on a thing like Photoshop, or I mean you could draw it on here if you want to. But this one's provided by Lumineer. I found it on their forum, so I feel that it's good for us to use. Alright, so now let's get started. We're going to want to start off with the line tool. You're going to see this cross up here. Now what we're going to do is that we're going to split this thing into different quadrants. So we're going to do one quadrant, and then we're going to copy it over to quadrant 2, quadrant 3, and then quadrant 4. So we're going to start out here. So see this cross right here? Line up your cross with that. Alright. Boom, and then we're going to want to drag that over. Make sure that you see the dotted green line. That means you're going at a 0-degree angle. Now you're going to want to go 102 millimeters, and then another 102 millimeters. Now why are we doing this? It's because when we split it up, then we're going to be able to do that a lot better. So now that we're going down, we need to divide 218 divided by 2, so that means that we are going to have 109. Alright, and then we're just going to split it up into our quadrants, so then we're just going to go with 204. We're just going to go straight up. So then we got our 90-degree angle. Then we're going to want to go here, and then we're going to see that. We're going to drag that straight down. Delete our other two like that, and then complete our quadrant. So then just drag that over like that. Plop it right down. So now we've got our quadrant. Now, what are we going to do with this quadrant? Well, we're going to select the polyline tool. We're going to start out at our base point on our quadrant, and we're just going to trace. So we're just going to go like that. We're just going to follow the black line. It's just like we were in 3rd grade. So it's going to want to follow the line, follow the line, follow the line, get down to here, draw a straight line across, and then we're going to want to use straight lines until we get to up here. We start to see some of the anti-aliasing in the photo start to go to the left. So now we're just going to trace around the left, trace around the left, trace around the left. Around the left, 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 left. Just gonna go down. Keep going, going, going. back up with the main plate, and then go straight back down. So we have our one section. We're just going to copy that, and we're going to paste it over in a new clean section. So I'm just going to paste it down here. And then I'm going to grab our motor mount for 1806 to 2204. I'm going to place that down a little bit because you're going to see what we're going to do. So now what we're going to do is that we're just going to select the motor mount. Hit rotate, R-O-T-A-T-E, and then you just type that in. So that's just how AutoCAD works. And then get it so that it's pretty much aligned with the bottom, like that. And then move it up so that it is pretty flush with the rest of the frame, like that. Okay, so now there is our first, well, sort of quadrant completed. But now we need to think, okay, so when I mirror this over, what do I need? Well, I'm going to need bolts. So to get the top plate on. So how are we going to do that? Well, luckily I provided our M3 nut. So now we can just put our M3 nut where we want our top plate to start and when we want our top plate to end. So we're just going to put one right there, and then we're going to put one directly below it, and then we could just make our line. Oh man, I was really close by sight. Okay, then we can just make our line going straight down, cancel, get rid of the extraneous line right there, and then move this over, and then plop it right there. There we go. Then you're going to see what we're going to do with that later. Now, also before we copy this over, we want to make sure that our desired propeller fits. So for a 250, we want a 5-inch propeller. Just drag this over and plop it right there, and then you'll see we got enough clearance so that we won't get any aerodynamic harmonization or clipping of the frame. So that we're good with that. Now we can just go. You're going to see the mirror tool up there. Select our base point, plop it on over. There's half of the frame. Get the other half of the frame on the bottom half. There we go. And now you'll see that when we measure from there to there, it's going to be very close to 250. We got 242. Which, if you want to, you can modify this so that it does reach 250. But for practice purposes right now, which is what this is going to be used for, it's close enough. Because you should not copy other people's designs, you should come up with your own. So as you can see now, we have our frame completed. Well, most of our frame completed. We're missing a very crucial component, which is going to be our flight controller mount. So you're going to want to select the line tool and then select 2 points directly across from each other. Now, why are we doing 2 points directly across from each other on the frame? Well, this is going to create an X, and this X is going to mark the spot where our flight controller goes, because a flight controller should always be in the center of a frame. So there's our X component. We can come up to our toolbox here, select our flight controller mount. We can not select the text of the flight controller mount. We can just select the flight controller mount. We can copy it, paste it, and move it onto mark our X here, and onto our X marks the spot. So as you can see, there we go. We've got our completely centered flight controller mount. And our top plate is going to go on those studs right there. So now, well, how are we going to make our top plate? Well, first off, we're going to remove any extraneous holes. So on the bottom here, those have got to go. And now we can make our top plate. So what I like to do is that I like to duplicate the frame, and I'll paste it over here. So now we have 2 frames. Well, why would we want 2 frames? Well, we can use a function called the break function, and we can break off portions of our frame that we don't need. So we could just go here, and we can get rid of our flight controller mount. We can hit the break, and now we can break our arm off of our quad, just like that. So now as you can see, oh, we took a little bit too much off. We can break it again, break our arm again, and then there we go. Now we can remove our broken arm. And now we can use quadrant method if we really want to. I'm going to just use it just to save a little bit of time because it's a little bit easier to do quadrant method instead of going through and deleting all the arms. But if you want to delete all the arms, go ahead. You can cancel that. And we can just remove all that, remove all that. We can just mirror this over. Okay, and then you're going to see, well, wait, this covers the whole bottom half of the quad. Well, we don't want that. So what we're going to do is that we're just going to remove all the extraneous lines. We're going to draw a line. Personally, I'm going to go about 3 down from there. Connect it to there. Oh, no. Actually, I'm going to go 5 millimeters down just to make it just a little bit safe. So it depends on what machine that you're going to get this cut on. Alright, so now that we got our reference point, now we can just draw our line from there over to there. There we go. Okay, now we can just break this last part off back here. Or we can just swipe and delete. And then you're going to see, oh, well, if we connect those, then it's going to be a straight line, and then it's not going to look good. So how do we fix that? Well, we use something called the fillet tool. Select here and select here. And then what yours is going to show up is that it's going to show up as a right angle, but if you hit the down arrow, then you can hit the radius tool. And I always like to use a radius of 5. I just think that it looks really smooth and really nice. So once you do that, you never have to set it ever again. So you can just go down here, fillet it, boom, boom, get rid of that extraneous piece. And there we've got our completed top plate, remove extraneous holes, and then what I like to do is just make a copy of it, and then paste it, and then go up here, go to move, and then make sure that all the holes line up on the aircraft. So as you can see, there we go, all of the holes line up on the aircraft, so just hit Control Z to undo, and then just hit delete. So now I've got most of our frame completed, except for our accessories. So in order to put the battery in, what are we going to need? Well, we're going to need a battery strap. So we could just snag our battery strap down there like that, and as you can see, it's just a little bit too wide, so I'm actually going to move it on in just a little bit. So I'm going to select each one. I'm going to move it in by about 6 millimeters. Seems to be pretty good. Move that in about 6. And move the other one in about 6. I'm going to want 2 battery straps in the back here, so I'm just going to make a quick reference line. But first, before we make the reference line, we're going to have to figure out what is the distance between these so that we can get the exact center. So as you can see, it's going to be about 37 millimeters. So I'm just going to go for a 16, just to make it so that everything has an even amount. So we go 16 mil. Oh no, we're not going to want it. So we're going to want to go for an 18. Actually, sorry, I did my math wrong. So 18 millimeters, and then go, I'm just going to use the mirror tool just to make sure that everything is absolutely perfect. So go mirror that down. I want to hit no, and then we're just going to mirror this object on the axis down. No, do not erase. Select these and move these down. It's going to lock, and then we're going to want to just go, okay, that's a pretty good spacing. So now we're going to go to our complete center of the quad, draw a line up, move these, select the center point right there, line it up with our reference, put it where we want it, and plop it right in there. Now everything is perfectly centered. So now we can just go up, delete that, and now we've got our perfectly centered battery straps. Now coming over here, we can copy these battery straps again if we want to add 2 options. So if we want to run a bigger battery on top, or we can run a GoPro and a smaller battery on the bottom. That works too. So of course we're going to redraw our reference line. So reference line right there, and then a reference line going directly up, or directly down, I should say, the frame right there. Now we're just going to want to go and copy this because we're going to have to paste it twice. So move it, center of reference. Oh no, we don't have the center of the reference line. So we have 36. That means we're going to have to go for an 18 and 18. Move it, center reference line, boom, line it up with there, drag it down, it's going to lock. So there's our first set, and then that can either take a GoPro or a, oh, does that one have the center reference line? No, it doesn't. Okay, we're just going to go for a quick, uh-oh, I enabled something. Nope. All right, I accidentally hit grid snap there. Grid snap is never fun. Just going to want to move this. And then slowly put it in, move it down, move down, move down. Oh, it collides just a little bit with our things, so I'm just going to put 1 strap at the back. Delete our extraneous straps like that, and then delete that, remove our reference lines, and there we go. We have our very own QAV 180-esque quadcopter. So yes, it actually is that easy to design your own to make and do it in AutoCAD your own quadcopter frame. So be sure to tune in on Wednesday when we're actually going to make this into a 3D model, and then we're going to be able to be like, hey, look at what I made in Inventor. And then we're going to learn some tricks on how to 3D print a unibody frame. Unfortunately, if you see down here, we're just going to go for a 200 by 200. This is how you can simulate. So I made a 3D printer bed. Now I can drag this. I'm just going to make a quick copy of it. Come on, AutoCAD, you can do it. There we go. So as you can see, unfortunately, this will not fit in my printer, so we're not going to be printing one of these out. However, you can use a service such as Shapeways to be able to get this printed out. They got all different types of shapes and styles. I've used them before. I've never gotten this video is not sponsored by them. But if you are a company or a 3D printer and you do want to sponsor one of these videos, be sure to email me in the email in the description or send me a PM on YouTube. So thank you guys so much for watching. Happy designing and happy flying. And like I said before, be sure to tune in on Wednesday so that you can learn how to convert this over into a 3D printed model. Thanks again, guys, and I'll see you on Wednesday.